Alright, here we're going to talk about absolute value inequalities. So we're going to talk about how you can solve those. And so what we quickly want to review in this case is we actually want to review inequalities, just to make sure you kind of understand. There's one tricky thing about inequalities. So what I have here is I have the number 6 and the number 1, and then I have the numbers -6 and -1. So you can see that -6 and -1 are just the opposite of those. It's as if I've multiplied through by a negative or perhaps divided by a negative to just change those numbers. So what I'm going to do is look at those on a number line. So if I do that, I have 1 is on the left and 6 is on the right. So the kind of the inequality sign always points toward the larger number, and the larger number is always to the right on the number line. So since 6 is to the right, the inequality sign we're going to put in here is greater than. It's kind of eating more fish. That's what I was always taught. Alligator eats more fish. And then when I graph -6 and -1, -1 is to the right on the number line, so the alligator is going to want to eat -1. And you can see that it's not really magic, but if you multiply or divide through by a negative, what happens is you actually change the relationship between the two numbers. Their relative positions on a number line, which is why you switch the inequality from one direction to the other. So what you typically say is that it flips the sign, and that's a big deal. So we're going to have to deal with that quite a bit. So let's take a look at the first method that I'm going to talk about is the method of just testing regions. So we have this absolute value inequality, so the absolute value of x plus 3 is greater than 5. What I'm actually going to do is I'm going to look at this similar problem, which is the absolute value of x plus 3 is equal to 5. So it's a different problem, but it's not very different. And I'm going to solve this. We should know that we get two different equations. One where the thing on the inside is the same, so x plus 3 equals 5. The other where it's the opposite. So the opposite of x plus 3 equals 5. And now if I solve each of these, so I subtract 3 there, I'm going to multiply through by a negative first and then subtract 3 here. I get that. So the numbers 2 and -8 actually have some relationship to the solution to the original problem. So x equals 2 and x equals -8 are the boundaries that we're going to use for our solutions to the original. And what I mean by boundaries is that I'm going to make a number line and use -8 and 2 as kind of the cut points, so it divides regions on the number line. And notice I didn't put 0 on the number line. You don't want to put 0 unless it's actually one of the zeros or actually a solution that you need to put on. Because what we need to do now is pick numbers that we're going to test. So I'm going to test in this region -80. In this region I'm going to test 0, and in this region I'm going to test 100. So I picked a number that's in the region. So from -infinity to -8, -80 is in there, so I'm going to use that. Between -8 and 2 is 0, so that's why you didn't want to put 0 on there. That would create extra regions, plus then you wouldn't be using 0. And 0 is the best number to use if you can. And then 100 is just really big. So by test, what I mean is I'm going to take these values and plug them into the absolute value of x plus 3 and see what happens. So for example, I have this, which gives me -80 plus 3 is -77. The absolute value of -77 is just +77. Since +77 is greater than 5, that region is part of the solution. Now I plug in 0, and I get just the absolute value of 3, which is 3. 3 is actually less than 5, which isn't what we want here, so that is not going to be part of the solution. So that region isn't included in our solution. And then 100 plus 3 is 103, and the absolute value of that is 103. 103 is greater than 5, which means that that region is a part of our solution. So now I actually know what my solutions are, so I can write them up. So if that's my equation, then my solution is either x is less than -8 or x is greater than 2. Okay, there's no way to combine those into one inequality, so that's kind of where that stops. The next method that I want to talk about is where you just kind of like math your way through it. So this is almost identical to the process of solving the equation, but now that flipping the inequality thing is going to come into play. So I have this. So what I do is I get two equations out of it. One where the thing on the inside is the same, and the other where you need the opposite of the thing on the inside. And so I'm going to solve each of these. So solving the left equation, I'm going to subtract 7, which is not multiplying or dividing, so it doesn't change any signs. And then I'm going to divide by 3. And it was dividing by a positive, so that doesn't change any signs. Now on this second thing, I'm going to first multiply through by a -1. That changes the relationship between the numbers, or between the quantities. So I actually have to flip that sign when I do this. So instead of having less than or equal to, I now have greater than or equal to, which I'll use a different color for, and then -13. Now I just subtract 7 to get that, and now I'm going to divide by 3, but it's +3, so it doesn't change the sign or anything. So those are kind of my two solutions, but what I'm going to do here is put those on a number line and take a look at them. So if x is less than or equal to 2, I'm going to put a solid dot at 2 and then shade kind of to the left where it's less than that. And then if x is greater than or equal to -23, I'm going to put a solid dot at -23 and shade to the right. The solution I'm looking for is between those, so it has to include both parts that I shaded. So the actual solution I want is right there, which means I can write this as a compound inequality. So that's what I would do. And those are the two methods that you can use. Either one works well. I find that testing regions for a lot of people is easier, because then you're really just dealing with an equation, and then you go back and test the relationship. So you might want to kind of use that one more than this one, but this is actually the method that I would use. But anyway, I hope you found this helpful, and good luck.